In our last module, Inference for One Proportion, we focus on making inferences about population proportions. The type of research question that we focused on then was just about population proportions with categorical data. We're going to build on that in this section. In this module, we'll look at the italicized and red text below. That's what we'll be focusing on. So the type of question, make an estimate about the population. Before we would say, what is the average number of hours that community college students work each week, for example? We've seen that, and that's a quantitative variable because the number of hours is a number. And because it's quantitative, we used inferences or means from that previous unit that we saw. Now we're going to look at something like what proportion of US adults support the death penalty. That's a categorical variable. There's no numbers. It's just, yes, I support it, or no, I don't support it. And we'll be using inference for one proportion. That's the name of this unit. And then, for example, if we were testing a claim about the population, questions that we've asked before, quantitative variable type questions where the answer is a number, has the average birth weight in a town decreased from 3,500 grams? We might ask more of a categorical question like, do the majority of community college students qualify for federal student loans? That's, a yes or a no categorical variable. And then if we would compare two populations, we used to ask questions like, are teenage girls more likely to suffer from depression than teenage boys? I think we saw an example like that in a previous module. Or in community colleges, do female students have a higher average GPA than male students? That would be a quantitative variable. It sounds like it wouldn't, because the answer might be yes or no. Yes, females have higher GPAs, or no, but I think in that one we would use GPA, the actual number, like 3.2 or whatever the GPA is. So that would be quantitative. Whether teenage girls suffer from depression more than teenage boys, there's no number that can really quantify that. So it'd be a categorical variable. And that was in previous modules that we've seen. So we're going to build on that in this module. We'll add two things. First being, we'll use more formal vocabulary and notation for hypothesis testing. So as if we didn't have enough more vocabulary, here comes some more. And also, we will not know the population proportion, so we'll make some minor adjustments to the model for the sampling distribution that we developed previously. The adjustments can affect how we calculate the standard error. Yeah, because I think most of the examples we saw in the previous module and maybe the module before, they told us the population proportion, like 0.6. I think that was 60% of college students are female or something, and they told us the population proportion, and sometimes you don't really know the population proportion. So that might be what we'll look at in this module. But just looking back at the big picture here, let's see. Here's a big picture. We highlighted ideas that are new to inference for one proportion in purple. So again, it starts with a population. You take a little sample of that population. The yellow circle is supposed to represent just part of the population, a sample. You produce data based on that sample. And then you do some kind of exploratory data analysis, which is mostly what we focus on in this class, right? And then here's your data. You calculate some probabilities based on that data and the data analysis you did. But the new part that we'll see is, well, what we saw before was, we'll see data in relation to random samples from the population. Okay, we've seen that before. And then we ask how much variability in random samples can come from this population. So a lot of times you take a lot of random samples to get a good idea of what kind of population proportion you could have. But the new part is we'll model variability with a normal curve. We did see that before. And then also adjust the model since we don't know the population proportion. So we'll have to do some adjustments to what we've done before, just imagining we don't have the population proportion. But then also from there, once we do that, we're going to test a claim about a population parameter. We'll conduct a hypothesis test, state a hypothesis about a population proportion, find a p-value, which we don't really know yet, based on an actual sample proportion. What is the probability that random samples have proportions that vary more from the population proportion than the data? The smaller the probability, the stronger the evidence against the claim. So we'll see some of that in this module. And then also estimate a population parameter. We'll calculate a confidence interval, which is just, I'm pretty sure that this is the population proportion plus or minus 2%. So it could be off by 2%. It could be higher or lower by 2%, which we've kind of seen before. This idea here, the sample proportion plus or minus the margin of error. We've seen that in the previous module. And will state the confidence level to describe the probability that a random sample estimates the population proportion with this margin of error.